I'll start the midterm exam presentation from now on. The table of contents is as follows. Monolithic microwave integrated circuits are now used extensively in communications, radar, and sensing systems. In MMIC device, active devices are gallium arsenide MOSFET, gallium arsenide high electron mobility transport system, gallium arsenide heterojunction bipolar transistor, and so on. Active devices amplify signals and have varying degrees of linearity. Choosing the materials is dependent on electron drift, velocity, mobility, and resistivity. In MMIC device, passive devices are inductor, resistor, transmission lines, and so on. Passive devices are used in MMIC layout and design for impedance matching, DC biasing, and phase shifting. Gallium arsenide MOSFET is bipolar element in which channels are created in Schottky diode shaped structures. They are almost depletion mode devices requiring negative voltages to control the gate. Because gallium arsenide has very superior electron mobility. The advantages of gallium arsenide include better performance, high impedance, and low parasitic capacitance. And the disadvantages are high cost and high threshold voltage demand. Gallium arsenide MOSFET are used mainly for exacting microwave applications both as a low noise signal amplifier and in higher power RF circuits. Indium gallium phosphide heterojunction bipolar transistor is general purpose amplifier. Heterostructure junction with a band gap difference between the emitter and base possesses a higher emitter injection efficiency and high current gain. The advantages are superior electrical transport and low cost. When a signal comes through the antenna of the receiver, the signal strength is very small, so a large noise is very better. For this purpose, LNA should be used to minimize noise and amplify the signal. So LNA is always in front of the receiver. The most popular type of receiver is the heterodyne circuit, which is shown in figure. This shows a simplified block diagram. The incoming RF signal from the antenna is first filtered by a low noise amplifier, which also suppresses the contribution of noise from the succeeding stages. The Smith chart is a complex coordinate system that represents real numbers on one axis and imaginary numbers on the other. The reason we need a complex coordinate system is because of the complex impedance. Real numbers are represented by resistance and imaginary parts are represented by inductance and capacitance depending on the sign. The relationship between the reflection coefficient and the load impedance is shown below. If you draw the above equation on the drawing, it becomes a Smith chart as it is. For example, if G0 is 50 ohms and a point is given in the Smith chart drawing, you can get 1 minus J by reading the Smith chart. And you can also get the reflection coefficient and the corresponding impedance. These are some examples of impedance transformation of transmission lines. If you try to find the impedance using an equation, when the value of length is lambda of 4, the value of tangent beta L is infinite. And when the value of length is lambda of 8, the value of tangent beta L becomes 1. Substituting this into the equation on the right, you can find G in. However, if we know how to read the Smith chart, when length is lambda of 4, it turns half a turn, and when it is lambda of 8, it turns 1 over 4 turn. So it is very easy to find impedance. Amplifier is an electronic device that can increase the power of the sign of a signal. And the reason for using an amp is different depending on whether it is a transmitter or a receiver. When using a power amp at the transmitting end, since the electromagnetic wave can reach the desired location only when the antenna emits the signal with the appropriate maximum power, the final power amplification is an important issue. When using a low noise amp at the receiving end, it is important to amplify while minimizing noise because the signal received from the outside is very small in size and contains very dirty noise. The variable gain amplifier amplifies the signal as much as I want. The mixer mixes the two frequencies and pulls out the frequency corresponding to the sum or difference. When two frequencies are input to a mixer using a linear element, a very complex frequency output is produced by the sum and difference of the frequencies, as well as the sum and difference of the harmonic components of the input frequencies. So many undesired harmonics are generated and they must be filtered. Mixers are usually classified into active mixer and passive mixer. The passive mixer can be implemented relatively easily, and the active mixer compensates for the insufficient power compared to the passive mixer. BJT consists of three doped semiconductor regions such as emitter, collector, and base. It is divided into NPN and PNP elements depending on the type of junction. Depending on the voltage difference between the emitter, base, and collector, there are four operating structures. We often use the active region and the saturation region. So, when you operate in active, it has a high signal gain. However, when it operates in saturation, it acts as a switch.